Hi everyone. So we start chapter 8, the generalized linear model. So this chapter is a little theoretical, more theoretical than the previous chapters. So I used the handwritten notes to explain some concepts. In later sections that we will have also some R code as usual. Okay, so at first the definition. So at first, I would like to discuss the motivation for the generalized linear model. So the motivation is to generalize the argument of the binomial and the count models. So the base is, excuse me, the base is the linear model. So we explain a linear combination of predictors. We explain response by a linear combination of predictors, but we have some transformation to accommodate the non-numeric response variable. So one may be categorical, and maybe another one may be some ratio, or at least the variable which does not range the entire real numbers. Okay, so before the definition that we revisit the logistic regression. So logistic regression, the formula for logistic regression is here. So probability of y is equal to 1 is equal to the inverse logit function of beta transposed x. So beta transposed x is the linear combination of intercept and the x1 to xp, the predictors. So beta, so t is the transpose, and beta is just a vector of beta naught to beta p. And inverse logit function is the e to the power z divided by 1 plus e to the power z. And this can be written as this way. So y is equal to I logit beta transposed x plus epsilon. So originally I did explain that the logistic regression doesn't have an error term, but we take the expectation. But the same thing, actually the second equation has the same meaning as the first one, because just we think about the difference between y and the probability of y is equal to 1, then we can still use that as epsilon, and we can say the y is the I logit the beta transposed x plus epsilon. So epsilon can have only two values. So epsilon is y minus I logit of beta transposed x, or actually this is expectation of y, so y minus ey. So epsilon has mean 0, so we can see this as an error term. So our objective here is we generalize this I logit function to a link function g, and we generalize this epsilon to some error following the sum distribution. And also we consider what kind of the link function is appropriate for many cases.